As we wait for more people to file in, may I have some volunteers who would like to try some of these problems, try solve some of these problems. Ryan, thanks for having your camera on. If the rest of you can also turn on your cameras, if that's an option, that'd be awesome. So Ryan Lin, would you like to try the first problem? So what would be your first step? We're just gonna speed through this and then we can move on to the actual lesson today. So um, what would you first try and do, Ryan? Any ideas? Ryan Lin? Okay, would anyone like to help Ryan Lin, please? Aaron, would you like to try the first question? 12 plus C equals 3 times 5. How would you find C? Yeah, I guess we're a quiet bunch today. Garrus, would you like to try the first problem, please?
Okay. So 12 plus C equals 3, so that means C equals 3. 12 plus 3, and then
Okay, I think Ziran posted the answer in the chat already, but Garrus, would you like to try and simplify the answer so that we actually know what Ziran might have done? For example, over here there's a 3 times 5, okay? It's not
there's 3 times 5.
So
Oh,
what's
3
3
times
times 5?
5 is 15.
15. Awesome. So we know that 3 times 5 is 15. So over here we have 12 plus C is equal to 15. Okay, what next can we do to isolate C?
Uh, oh,
So remember,
well,
pardon? Go ahead, yours.
so we put 15. Oh,
So remember, when we isolate C, we only want the C on one side, okay?
okay, so we put the C.
So
Okay,
we does
put
this
the
so
so put the 15 over there.
not exactly. So if we want to just have the C, what's being annoying right now? So when we look at a math equation, we concentrate on what's annoying. Okay? We have a C, but then we have a plus 12. We don't like the plus 12. How do we get rid of that plus 12, Gears?
Put the 12 over somewhere else.
Exactly. We go like, okay, you're not over here. We're gonna move you to the right side. So how would we get rid of the 12? Do we add another 12? Do we divide by 12 or do we subtract by 12 or divide by 12?
Subtract by 12.
Subtract by 12. Why so? Why do we need to subtract?
Because if you add 12, then you'll just get an even higher number.
Exactly. It's even more annoying. So we need to subtract 12 to get rid of 12 on the left side. But do we only subtract 12 on the left side?
Uh, no.
No. Well, the reason we don't is because we have to be fair, right? If we subtract 12
Yeah.
on the left side, we have to subtract 12 on the right side. So we have 12 plus C minus 12, which just gives us C. And then what is 15 minus 12, Garrus?
15 minus 12 is equal to 3.
3. Awesome. Okay, just to verify that Ziren and Garrus are correct, Aaron, would you like to try and substitute 12 plus 3 and verify that the answer is correct? If Okay, Henry, would you like to substitute for Aaron, please? So what is 12 plus 3?
It's 15.
15, awesome. And we just, what is 3 times 5?
Wait, 15.
Also 15. So we see that C equals 3 is the correct answer. Thank you, Henry. Would you also like to try the second question? The P minus 4 one over here. So how would you start with that one? Henry? Uh, okay. As you ran quick to the answer again, I'm pretty sure 2. Oh, oh, sorry. So Henry, were you saying something? Can you help me with the second question, please? So we have P minus 4 equals 11 minus 5. What can we try first to simplify this? Okay, if Henry isn't here, I'll ask Jager. Would you like to attempt this question?
Okay, P is 10.
He is 10. Why is it 10, Jager? Can you tell me why?
11 and 5 is 6. 6. P
Okay.
and 4 is 6. 6 and 4 is oh no, 11 and 5 is 6. P and 4 is 6 and 6 and 4 is 10.
So what is 6 and 4? Because I know you said 6 and 5 is 6. 11 so when we do math, we want to be specific about our operations, okay? So if you
Okay.
see a subtraction sign, you say 11 minus 5, okay? So
Okay.
we have 11 minus 5, you got that correct, it is 6. But then when you have a 4 and a 6, you try and add a 4 on both sides so that the P on the left side is isolated, or there's nothing left other than a P, okay? So we add
Okay.
4 on the left side, and we add 4 on the right side. So -4 plus 4 is nothing. All we have left on the left side is a P, right? And
Yep.
what is 6 plus 4, Jager? I think you had the answer a while back. So 6 plus 4 is
10.
10. Awesome. Can you verify this for me, just in case, we might have gotten it wrong? So if we put 10 back into our original equation. Jager? So what is 10 minus 4? Okay, I guess I'll move on to Ryan Lin. Can you tell me what 10 minus 4 is, Ryan Lin?
What?
What is 10 minus 4?
10 minus 4, 6.
6, good. And what about 11 minus 5?
Mm, 6.
Also 6. Awesome. So we know that 6 is equal to 6, which means our answer of P equals 10 is correct. Ryan, while you're still here, would you like to try 7x equals 20 plus 8?
Mm. Mm.
So our first step would be to try and simplify the equation a little bit. So 7x, we could try doing something, but what about 20 plus 8? We can definitely simplify 20 plus 8, right, Ryan?
Yeah,
Yeah, so what's 20 plus 8?
20 plus 8 is 8. Or 28. Sorry.
28, yes. Okay, so then we have 7x equals 28. How do we, make the x all by itself? Or how do we isolate x?
Mm.
So if you remember from my previous lessons, the x is being multiplied by 7. So what's the opposite of multiplication? If you multiply by something,
Division?
division. So if you multiply x by 7 to get rid of the multiply by 7, what do you have to do?
What?
If you multiply x by 7, how do you get rid of the 7? You divide by
Hmm.
7, right? Right?
Yeah.
Are you following along?
That's sort of.
Okay. So if you divide by 7 on the left side, what happens on the right side?
Hmm.
So remember, you have to be fair. If you divide by 7 on the left, you also divide by 7 on the right. So 7x divided by 7 is, Ryan, is simply x, right? Because the 7 and the 7's cancel out. What about 28 divided by 7? Um, so Ryan, do you know what 28 divided by 7 is? Can someone help out? Aaron, can you tell me what 28 divided by 7 is? 4. Okay, thank you, Aaron. Appreciate your participation. Okay, Garrus, I'll trouble you to verify this once again. Um, so what is, if we bring x back into 7x equals 20 plus 8, can you confirm for me that this equation is true?
Yeah, I can confirm.
Okay, so 7 times 4 is what?
All right. 7 times 4 is 28.
Perfect. And what is 20 plus 8?
20 plus 8 is 28.
28. So we have 28 on both sides, which means our answer is correct. Henry, would you like to try the fourth one, please? We're trying to speed through this, so we can move on with the lesson today. Henry, would you like to try 5 times 7 equals 50 minus Z, or Z, depending on what you like to call them? So where will we start for this equation? Okay, I guess I'll move on to Jagger. Can you try 5 times 7 equals 50 minus Z?
Okay, 5 times 7 is 35.
Awesome.
A 50 subtraction z is 35. 50, uh, 50 subtraction 35 is 15.
Are you sure about that? So
Yeah.
where do you, from 35 equals 50 minus Z, how would you isolate Z? So what did you do from this step to the next? Jager? So did you add a 50? Did you subtract a 50? What did you do? Did
Uh,
you, or,
it's a um
are you not too sure? Because,
yeah.
well, I'm pretty sure you got the correct answer, but when the math starts getting hard, you need to be sure every single step you take is correct. That way, when I mean, the questions we're doing right now are relatively easy, but once the steps start getting really complex and you just, try doing it in your mind, it's not, I mean, it's not impossible, but it just gets more and more difficult the higher math levels you
It's
get, right?
6:15.
So in this case, remember, we want to isolate for z, okay? And right now we see a
Okay.
50 minus z. So what number is next to the z, Jagger?
It's 35.
So like next to the z, there's a number next to the left of the z. There's a
Oh, Z is 15.
Okay, yes, z is indeed 15, but we want to make z on its own. Okay,
Okay.
so if we want to make z on its own, it's not on its own right now, right? It's right next to the 50. So how do we get rid of the 50?
Okay.
Jacob, do you know how to get rid of the 50?
Yeah.
Uh, it's positive 50, so to get rid of 50, how would you get rid of it? You can do what? You can subtract by 50, okay?
Okay.
Because positive 50, the opposite of positive 50 is negative 50. So if we subtract by 50 on both sides, so we have 35 minus 50, which is same as 50 minus c minus 50. So what is 35 minus 50, Jager?
On 50,
Okay, these numbers are actually a bit big. Actually, if you're not comfortable with negative numbers, I totally agree. It can get a bit, get a bit confusing sometimes. So let's do this another way, actually. In this case, instead of moving the 50, we can move the z to the other side. Okay, so
okay.
what happens if I add a z on both sides? Watch what happens. So if I add a z on the left side, I just get z plus 35, right?
Yeah.
Yeah. So I can't just, add z on the left side and not bother with the right side. So what's 50 minus z plus c, Jager?
Z, Z, it's 35, it's 50.
Right. So the z's cancel out, and all I get would be z plus 35 equals 50. Awesome. And now we can do what I think you've been wanting to do all along. I'm gonna move this up here. So z plus 35 is 50. How do we isolate the z now?
On 50 subtraction 35, it's 50.
So if we subtract 35 from both sides, we get z plus 35, right?
Yeah.
Plus
Yeah.
35 equals 50. And then we subtract 35 on both sides. So you said 50 minus 35 is equal to 15. So in the end, we have z is equal to 15. Can you verify this for me, please? So
Okay.
I got rid of some of this messy stuff. Um, what is 50 minus 15? There you go. So 50 minus 15 is, okay, Garrus, I'll have to ask you to help to kick in for Jagger, please. Can you tell me what 50 minus 15 is?
0.
Sorry, 50 minus 15.
Oh, I thought you said 15 minus 15.
Yes, sorry, it sounds very similar.
35.
35 and 5 times 7 is
5 times 5 is 25.
5 times 7.
Oh, 5 times 7?
Yes.
Oh, I thought it was 5 times 5. Okay.
So 5 times 7
5 times 7 is 35.
is also 35. So we see that 35 is on the left and 35 is on the right. So we know that z is equal to 15 over here. Okay, I think we should. Okay, let's just do the question with the y, and then let's move on to our next part of class. So, um, Aaron, would you like to try 14 minus y equals 40 over 5, please?
Um, First subtract 14 from on both sides.
Okay, we can try that. Let's try subtracting 14 on both sides. And what do I get?
0.
Okay, 0. We get 0. And then,
And do 40 minus 14.
so on the right side is 40 divided by 5.
Oh, do 40 divided by 5.
Okay, so let's do 40 divided by 5. What's 40 divided by 5 first?
8.
8. Okay. Actually, before we do 40 minus 4, so before we subtract 14 on both sides, I'm just gonna assume we did the division first. So we have 14 minus y is equal to 8. Let's just write that down so it's not too messy. So 14 minus, oops, 14 minus y is equal to 8. And then you said subtract 14 on both sides. Good move. So we subtract 14 on both sides. And on the left side, what do you say it was again? So on the left side,
0.
you said it was 0.
Yeah.
Okay, so the left side is 0, and the right side is
26.
the right side is what again?
26.
26 or -6?
26.
26. Are you sure about that?
Yeah.
26? The answer is 26, you think?
No. 14 minus 8.
Okay, remember, before it was 14 minus y equals 8, right?
Mm-hmm.
And then you subtracted 14 on both sides. So on the left side, instead of 0, I get where the 0 is coming from, but there's also the negative y you didn't touch. So over here, it would be 0 minus y. And usually we don't write the 0, so it's just negative y, okay? But on the right side, we have 8 minus 14. And that's something completely different from, I don't know, 8 plus 14, or 14 plus 8, or 14 minus 8, okay? Do you get that, Aaron?
Yeah.
Yeah. So, do you know how to subtract? Do you know how to do negative numbers yet?
Yeah.
Yeah. So, what is 8 minus 14?
-6.
-6. So we have 8 minus 14 is equal to -6. Now, that looks very nice, but we have negative y equals -6. So how do we get rid of that negative?
Add.
That is a good idea, but you see a negative on both sides. And another way to get rid of a negative is to multiply by another -1. Or you can divide by a -1, whatever you prefer. So, do you know what a negative multiplied by a negative is, Aaron?
No.
No? Um, okay. Uh, maybe this wasn't a very good question to end with, but I'll just give it to you. If you multiply or divide by either -1, let's say you divide both sides by -1, okay, that just cancels out the negative. Or actually, let's not even use division and whatnot. So if we want, okay, you were correct, Aaron. We can add y on both sides. Okay. So what happens if we add y on the left side? Aaron?
Get 0.
Yes, we get 0. So we have add y on the left side and add y on the right side. So we have 0. Yeah, let's go down a little. We have 0. 0 is equal to y minus 6. And how do we isolate y? This is a 0, by the way, not another 6. So there's the -6 being kind of troublesome on the right?
Mm-hmm.
So how do we get rid of the -6?
Add.
Add 6, right?
Yeah.
Yeah, so we add 6 on the right and we add 6 on the left to get 6 equals y, or y equals 6. We usually say it y equals 6. So can you verify for me that y equals 6 is the correct answer, Aaron? Let's bring it back to the top. So what is 14 minus 6?
8.
8, and 40 divided by 5
8.
is also 8. So we see both of these are correct. All right, I'm gonna skip the sixth question for now, and we're going to move on to some slightly harder equation problems. So over here, I have two unknown blocks, okay? Two unknown blocks on one side of scale. One block I know weighs 1 gram, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9 squares, 9 grams. So I'd like to set up an equation at the bottom here and try and find out how much these these question mark Mario blocks weigh. Okay, I know they're not the same color, but let's just call them X. Okay, these grams, these question mark blocks are called X. So how many X's are there? Jagger, would you like to answer for this for me, please? On the left side. Let's fill it in. So how many blocks? There's 1 block, and then there's 2 blocks. Right, Jagger? Two green blocks. Are you following? Okay, Aaron, can you confirm that there are 2 green blocks on the left?
Yes.
Yes. So we have 2x on the left because we don't know how much they weigh. They could weigh, I don't know, a ton. They could weigh 1 gram, or they probably don't weigh anything at all. Maybe they're empty boxes. What about this? There's 1 gram on the left. So what can I put here? For the
1.
1? Exactly. Okay, so what about the right side? How many ones are there, Aaron?
9.
9. So we have 2x plus 1 equals 9. Okay, so that's nice, but I want to find x.
其实有点会。
Okay, so just using the scale, how can I find x? What do you suggest, Aaron? So if I were to, for example, remove 1 block at a time, or because if you ever played with a scale and you have 2 equal masses, but if you remove like 1 block off of it, then the mass is gonna whoop, it's just gonna like tilt on one side, right? So we want to remove equal masses on each side. Okay, so this one is sort of causing trouble. It's like some extra little thing. We can delete it on this left side, and we can also delete it on the right side. So what do we have now, Aaron?
8.
8. So we have 8 blocks on the right. Oops. We have, sorry. We have 8 blocks on the right, and we have 2x on the left. Okay, what now?
8. Do 8 divided by 2.
Exactly. So we can divide each side by 2. So if we divide 2 blocks by 2, then one of the blocks will disappear. And if we divide this side by 2, then half of the blocks will disappear. Okay, so for every other block, I'm just going to delete 1, 2, 3, 4. Okay, so what do we have now? We only have 1 on x on one side, and on the right side, we have 4. So what does this tell us?
X equals 4.
Exactly, x equals 4. So we found that from the original 2x plus 1 equals 9, we were able to break it down to x equals 4. Let's try another one. So over here, now we have lots of blocks, actually. Garrus, would you like to list the equation out, please? Write the equation out. So on the left side, what do we have?
4.
For what?
4 X's.
4 x's, exactly. So there are 4 blocks of x. This is kind of being good.
Yep, there's 4 blocks of X's.
There are 4 boxes of x. So what about the right side? I know it's a bit
There is 1 block of X and then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 blocks of
It's
1.
6:30.
awesome. So we see there are 9 blocks of 1 on the right. So how can we simplify this, Garrus? How can we find what x actually is?
Uh, uh, so 4x's is equivalent to 1x plus 9.
Mm-hmm. So in this case, we'd like to get rid of, because on the right side, it looks a bit annoying, right? There's an x and a 9. We don't really know what x is, and then there's just an extra 9. But
Yeah.
the thing that's actually causing problems is the x. So
Yeah,
what do
that's
we do with
exactly
x?
what I thought.
Okay, so how do we get rid of this problem?
We take the x.
Yeah, we just delete it. Boom, it's gone. But oh no, the scale's tipping.
Yeah.
You see the scale's tipping? Oh, it's not actually tipping. But
But why is it not tipping?
well, I guess so the scale's tipping because
Now it's tipping.
actually it should be tipping this way. Sorry. It should be tipping this way because I got rid of one x on the right side, but you just took a weight off on the right side. So now the left side is heavier. What do I have to do on the left side to counterbalance what I just did? Yes, because we deleted one x on the right side, right?
Yeah.
Well, what should I do on the left side?
So what should we do on the left side?
Remember, we need to be fair to keep it equal.
Take
If I
one
delete
off.
something on the right, exactly. So if I delete something on the right side, I also need to delete something on the left side. So now this is equal. We have 3x. If I write this equation properly, we have 3x. I deleted the x equals 9. Okay. So now all the x's are on one side and all the actually known numbers on the other side. And I'm pretty sure we can solve this. We have 3x equals 9. And how do we isolate x, Gears?
Okay. So we
So you can look at the bottom. We have 3x equals 9. So how do we isolate for x?
so we put the x
We
somewhere.
want just the x. So our final product should look something like x equals something. So how do
Yeah.
we go from 3x to x?
We take a few more.
Sure, we could take a few more x's off, but how do I know how many ones to take off? We don't know yet, right?
Yeah.
I'm not too sure. So we can do something else, and from 3 to 1. How do you get there?
Okay.
Because the x is multiplied by 3, right? And to get rid of
Maybe
multiplied to get rid of multiplied by 3, what's the opposite of multiplication?
division.
Division, exactly. So if we have multiplied by 3x, we need to divide by 3x, or we need to divide by 3 to get only an x. So if we divide by 3 on the left side, I'm going to do that right now. So we divide by 3, I'm going to merge all these 3 into 1. And unfortunately, the balance is tipping again. What do I have to do on the right side? Yes?
Okay.
I divided by 3 to the left. What do I have to do on the
Remove
right?
some of the ones.
Exactly, I have to divide these by 3. So for every other 3, I'm going to have to divide by 3. And so what is 9 divided by 3, Gears?
Okay. 9 divided by 3 is 1, 2, 3.
9 divided by 3 is equal to 3. So we have that x is equal to 3. So we found our answer. I think the original one, if I go back far enough, was something that looked like 4x plus x plus 9. So can you verify that 3 is the answer, please, Garrus? So if I plug
Okay. 3 is the answer.
yes. So first check the left side. What is 4 times 3?
Oh, 4 times 3 is, let me just, 2, 3, 12.
12, okay. And what is 3 plus 9?
3 plus 9. 3 plus 9 is 12.
3 plus 9 is also 12. So 12 balances 12, and this balance is fair. It's balanced. It's living up to its name. So I think you guys should know by now, at least, how to solve two-step equations. We had 4x equals x plus 9. We could simplify it down, and then we got x equals 3 as the answer. But now something else I want you guys to do is, just staring at like a picture, I want you guys to try and write out an equation. So Jagger, would you like to try writing out an equation to represent this tape diagram, please?
Okay. This is a 17.
Pardon?
Okay.
Repeat again, please.
35 subtraction 17.
Okay. So by what I mean by writing an equation is, we want to make these two things equal. Okay. So we know that tape. Let's call this tape ribbon A. Okay. This is tape
Okay.
ribbon A, and this is tape ribbon B. And we know these two, they look the same length. So we're just gonna say that ribbon A is equal to ribbon B. Okay.
Okay.
So that's not very specific, right? Just saying ribbon A is equal to ribbon B, that you don't have any numbers, right? So we want to see how we know that ribbon B is 35, right?
Yep.
So 35 is equal to something. What is that something?
It's H 17. It's 35.
Yeah, so A plus 17 is equal to 35. And I think you are on the way to solve this equation. So how would you get just A?
A is 35.
So A is 35, what?
Subtraction 17.
Minus 17. Okay. So what is 35 minus 17?
It's 18.
A is 18. Okay, now just to check, if we throw 18 back into our original equation here, what is 18 plus 17?
It's 35.
35, and 35 is equal to 35, so we got this one right. Thank you, Jagger. Okay, let's try this second tape diagram. Now as you'll see, there's no numbers on the top. So if we call this tape ribbon A again, and tape ribbon B on the bottom, how can we write an equation for this one? Aaron, would you like to give this one a try?
There are 6. It's 6 cubes.
Mm-hmm. And they all have length p, okay? So we have 6p equals what?
120.
Equals 120. Awesome. So we see that this 6p's, if you put them in a row, it's exact same length as 120. Now, how do we find p?
120 divided by 6.
Exactly. So if we divide each side by 6, we get 120 divided by 6, which is
20.
120 divided by 6 is indeed equal to 20. Let's check it just in case. What is 20 multiplied by 6, Aaron?
120.
120. So 6 times 20 is 120. This is correct. We know that p is 120. Awesome. Okay, now let's try these hanger images. Aaron, do you mind if I asked you to try one of these once again? They are a bit difficult, I think. Maybe the first one. Can you write an equation for the first image, please? So we have, I can zoom in a bit if you want. We have 3/5 on the right side, and we have 1/5 and a z on the left side. And as you might be able to see, they're balanced, which means they have equal weight. So how would you write an equation to represent this image?
First, you add this 3 out of 5 and the 1 out of 5.
Okay. Are you saying you just add them to get the z? Do you think that makes sense? Did I hear a no in the background?
Z minus 3 out of 5.
Not exactly. You see, these two, we can imagine this as like a giant box, okay? So if we, threw them in a giant box, then we know that this giant box weighs the same as 3 over 5, okay?
Mm-hmm.
Do you see that? So this means that 3 over 5 has to equal whatever is in the giant box. And we know one thing in the giant box is 1 over 5, right?
Mm-hmm.
So 1 over 5 is in the giant box. And the other thing in the giant box is a triangle. The triangle we're calling Z has weight of Z. So that means 1 over 5 plus Z is equal to 3 over 5. Do you kind of see that, Aaron?
Yeah.
Yeah? So would you like to try solving for Z, please? I know these 5s look like an S, but bear with me. So how would I solve for Z?
3 out of 5 plus 1 out of 5.
Okay, so remember, when we're manipulating equations, we want to isolate the variable. Okay, even if they're fractions, I can like throw decimals at you, and you should be able to know that we just want to isolate the variable. And in this case, z is the variable. We don't know what z is yet. So what's causing trouble for us? It's not isolated, but what's the thing causing trouble?
Z.
Um, z is what we're trying to find. But there's like a neighbor next to Z. It's being annoying. How do we get rid of this neighbor here?
Subtract 1 out of 5.
Exactly. So we need to subtract 1 out of 5. If we subtract 1 out of 5 on this side, what do we have to do on the right side? Aaron,
2.
also subtract 1 out of 5. Okay. So we have 1 over 5 minus 1 over 5. This is 0. 0 plus Z is on the left side. We can kind of just ignore this. We just have Z on the left side. What about the right side?
2 out of 5.
2 out of 5. So Z is equal to 2 out of 5. Awesome. Can you verify this for me, please, Aaron? So if I actually replace this Z with like a 2 over 5 block, would this balance still be balanced?
Yeah.
Yeah, because why?
2 out of 5 plus 1 out of 5 equals 3 out of 5.
Awesome. So I think you got this. Would you like to try the one with a star on the right? I think the star one's actually slightly easier. Once you start getting a hold of the concept. So let's start with listing an equation, okay? So we have the 9 is balanced with a 2 and a star, right?
Mm-hmm.
So how would we write the equation? Aaron? So on the left side, what do we have on the left side?
9.
9. All we have is a 9, a lonely 9. So 9 is equal to some big box of stuff. Okay, the big box of stuff weighs the same as the 9. That's why the balance is balanced, because otherwise they just wouldn't be balanced, according to our laws of physics. So what's on the right?
2 and C.
2 and C. So what's that? Is it 2 minus C, 2 plus C, 2 times C? What is it? Aaron?
2 plus C.
2 plus C. Awesome. So how would we solve for C? What would we need to do to isolate C?
Minus 2
Minus 2. So we subtract 2 on the right side and
on the left side.
on the left side. Okay, so let's try the right side first. What's 2 plus C minus 2?
0.
It's not 0. We didn't touch the C, remember? So it's what, Aaron? So 2 plus C minus 2. The 2 minus 2 does cancel out, right? But we still have the C. Do you see that? Like, just because we undid an operation, it doesn't mean it's 0. Okay? So if there's still a variable that we haven't touched, the variable is still there. So C is still on the right side. Okay?
It's 6:45.
Are you following, Aaron?
No.
I've kind of noticed that like if you do like a subtraction or something, you just say 0 is the answer. But because we usually don't touch the variable when we're doing something like this. So the variable is still there. C is still there. Okay. Do you want to continue, or are you still having trouble?
Continue.
Okay. So what's 9 minus 2? It's
7.
9 minus 2 is 7. So we have C is equal to 7. Let's check just in case. We have 2 plus C. So what's 2 plus 7?
9.
9, and 9 is equal to 9. So this balance is balanced. Awesome. Let's see. Okay, I think that's about it. I actually have a video about the distributive property, but with variables this time. So if you remember last class, we were talking about the distributive property, where if you had something like A, if I go back here, if I had something like A times B plus C, Garrus, would you like to tell me how I can expand this, please?
To expand it,
So
Oh.
what did the distributive property tell us?
the distributive.
I know you might not remember, but it's actually very important for future math classes. So if you have A times B plus C, you can multiply inside.
Times C.
So
You
you
can
have
actually multiply it.
exactly, you can multiply both of the values inside to get A times B plus A times C. Okay. You can do this with any number of variables. You could have A times B plus C plus D plus E plus all the way to Z, and then you can still multiply it all the way out, right? So you can do AB plus AC plus AD plus AE, so on and so forth. So this is basically our first touch with variables, and let's see how.
Well, let's see, I have applied the distributive property, and we have 1/2 times the expression 2a minus 6b
can you guys all
plus
hear
8.
this?
So to figure this out, I've actually already copy and pasted this problem onto my scratch pad. I have it right over here. 1/2 times 2a minus 6b plus 8. Actually, let me just rewrite it. So I'm going to take it.
Sorry, I think it's a bit sped up.
Apply the distributive property, and we have 1/2 times the expression 2a minus 6b plus 8. So to figure this out, I've actually already copy and pasted this problem onto my scratch pad. I have it right over here. 1/2 times 2a minus 6b plus 8. Actually, let me just rewrite it. So I'm going to take it, let me color code it too, just for fun. So this is going to be 1/2 times, give myself some space, 1/2 times 2a minus 6b. So 2a minus 6b minus 6, let me write it this way, minus 6b, and then we have plus 8. Plus, and I will do 8 in this color. Plus 8. And so I just need to distribute the 1/2. If I'm multiplying 1/2 times this entire expression, that means I multiply 1/2 times each of these terms. So I'm going to multiply 1/2 times this, 1/2 times this, and 1/2 times that. So 1/2 times 2a, so it's going to be 1/2 times 2a times, let me do that same color so you see where the 2a came from. 1/2 times 2a minus 1/2 times 6b minus 1/2 times 6b times 6b plus 1/2 times 8. 1/2 times 8. And so what's this going to be? Well, let's see, I have 1/2 times 2a. 1/2 times 2 is just 1, so you're just going to be left with a. And then you have minus 1/2 times 6b. Well, we could just think about what 1/2 times 6 is going to be. 1/2 times 6 is going to be 3, and then you still are multiplying times b. So it's going to be 3b. And then we have plus 1/2 times 8. Half of 8 is 4. Or you could say 8 halves is equal to 4 wholes. All right, so this is going to be 4. So it's a minus 3b plus 4. A minus 3b plus 4. So let's type that in. It's going to be a minus 3b plus 4. And notice it's literally half of each of these terms. Half of 2a is a, half of 6b is 3b. So we have minus 6b, so it's going to be minus 3b. And then plus 8, instead of that, half of that, plus 4. So let's check our answer. And we got it right. Let's do another one of these. So let's say, so they say apply the distributive property to factor out the greatest common factor. And here we have 60m minus 40. So let me get my scratch pad out again. So
Now skip a little bit
putting it
because I
spaced that
think there's some
so
extra stuff.
factor, and you say, well, Sal, how do you know that? Well, because 4 and 6 still share a factor in common. They still share 2. So what if you're actually factoring out the greatest common factor, what's left should not share a factor with each other. So let me think even harder about what a greatest common factor of 60 and 40 is. Well, 2 times 10 is 20. So you could actually factor out a 20. So you have 20 and 30m, sorry, 20 and 3m, and 40 can be factored out into 20 and 2. And now 3m and 2 share no common factor. So you know that you have fully factored these two things out. Now, if you think that this is something kind of a strange art that I just did, one way to
I think that's about it for the distributive property with variables. I'd actually like some of you guys to try a few problems. But first, do you guys know how to factor something like this? If I asked, what is x squared plus x? Can someone in the chat or someone pop on the mic tell me what is the greatest common factor, or like what do they both share in common, for example? Garrus, any ideas? So for x squared plus x.
They are both x.
Exactly, they both have an x in common. So what is x squared divided by x? Do you know what x squared divided by x is? Garrus? So what's x squared divided by x?
X something.
Well, remember, x squared is actually the same thing as x times x, okay? So x squared is just x times x. So if we have x times x divided by x, what do we have left?
X times x, and it divided by x.
Is equal
Oh, this is hard,
to.
bro.
We're assuming x isn't 0 for now, just for the sake of this problem.
Okay.
So remember, any number divided by itself, what is it?
Any number divided by itself is 1.
Is 1. So if I told you, what is a million divided by a million? Or if I asked you that, what would that equal to? So a million divided by 1 million. It's, Garrus?
Okay.
What's 1 million divided by 1 million?
1 million is 1.
Right, so if you divide any big number or any number except for 0 by itself, you get 1. So we have x times x divided by x. These x's cancel out, so what do we have left? What do I have left on this side? I just have an x, right? Right, Garrus?
Yeah.
And what about x divided by x? You just did that a while ago. So
But
x,
I must be
x
x.
is pardon?
X divided by x is probably 1.
Is 1. It is 1, okay?
Yeah.
So remember, we started with x squared plus x. And you found that it's the greatest common factors that they have is x, right?
Yeah.
So how did we get from x squared plus x to x plus 1? We actually had something that looked like this. So to factor, I'm just gonna get rid of all this stuff in the middle. To factor x squared plus x, you found that the greatest common factor was x, right? So
Okay. Yeah.
so we could take out an x by dividing them both by x to get x times x plus 1, right? So that's how we factor them. We find the greatest common factor, and then we take that out. So we get x times x plus 1 equals x squared plus x. If you want to check, you can multiply it in. So what's x times x? Here's
X times X, 1. Oh, wait, no.
x times x,
So,
or how do you simplify it? It's just x squared.
times
So x
squared.
times x is x squared. Yes. What about x times 1?
X times 1 is 1. Oh, wait. X. So x squared plus 1.
Not exactly, because remember, x times 1, anything times 1 is just itself. So x times 1 is just
X times 1 is X.
x times 1 is just x. So we see how we went from x squared plus x to x times x plus 1, and then we went back to x squared plus x, which means these two are like interchangeable, right? I don't think that made a lot of sense. So we can try something like this. Let's say I have 6x squared. Actually, let's try 36x cubed plus 6x squared. Okay, let's try factoring something out. Garrus, can you tell me what these two have in common? They have, like, what are they both divisible?
They are both, they both, um, uh,
Would you like some help?
okay.
Okay. Um, so over here, we see that is 36 divided by 6 divisible by 6? Garrus? Yes? Or what?
Uh,
Is 36 divisible by 6?
Let me think. Is 36 divisible by 6? Let me
Oh,
think.
we can try breaking it down, okay? So
Uh,
what is 36 divided by 6?
36 divided by 6.
Is 6 times
6 times 6.
exactly. So 6 times 6 is 36, and then it's times x times x times x. Because x cubed is 3x's multiplied by each other, right? And then what about 6x squared? How can we break that down? Here's so 6x
Okay. 6 times 6.
so 6x squared is just 6 times x times x.
Times X.
That's it. So this is how we can break them down. And we see there's a 6 times x on the right, and there's also a 6 times x on the left, which means we can factor this out, right? Are you following, Gears?
Yep.
Yeah. Okay. So by factoring out, we can take 6x squared. And what do we have on the left? We took out 6 times x, which means this is out. We still have a 6, right, Gears? And we still have an x.
Yeah.
So over here, this would be 6x. But over here, we took out 6 times x, which means we have nothing. So do we put a 0?
Yeah.
Are you sure?
Oh, wait. No.
Then what do I put if I can't put a 0?
Uh,
I put a what?
yeah.
I put a 1. Okay.
1.
Because 6 times x divided by 6x squared, it's just the same as divided by itself. So you get 1. And to verify this, can you multiply this out, Gears? So what is 6x squared times 6x?
6 times squared.
It's 7 o'clock.
So 6 times 6 is
6 times X is
6 times 6, Gears.
Oh, 6 times 6. So 6 times 6. Okay, 36.
36, okay. And what's x squared times x? So remember, x squared is x times x times x. And how can we simplify that? So there's 3 x's in a row. All multiplied by each other. It'd just be x cubed, Gears.
Okay.
So we have 36x cubed. And then if you remember the distributive property, we distribute the first side, and then what's 6x squared times 1? So we already distributed 6x squared times 6x, and then we also have 6x squared times 1.
Okay.
Okay, so what's 6x squared times 1?
6 times 4 times 1.
6x squared.
Oh, it's 6x squared. 6x squared.
Exactly, it's just 6x squared. So we see that 6x squared times 6x plus 1 is the same as 36x cubed plus 6x squared.
Okay.
I think that may have gotten a bit too complicated, and I may have ran into a bit of a tangent down there, but if you guys do have the time, you can join the Kahoot. I'm sorry I kept you guys for a bit longer than usual, but if you guys would like to join, you can do so right now. Okay. Thank you, Aaron, for joining. Garrus, Ryan, Jiren, are you guys gonna join? I guess it is gonna be a bit boring if Aaron's the only one participating. Okay, if no one is I'll start in a minute. Are you guys gonna join? Garrus, Ryan, Jiren? No? Okay. Well, I guess it's just you, Aaron. Let's go through the questions. Great. I see you're getting this, Aaron. I'll just move through this real quick. Awesome. Nice. Yeah, I think you're getting this. Okay. Can you tell me if that was a misclick, Aaron, or did you actually think this was the correct answer? Because in this case, remember you can simplify it by dividing both sides by 9, but you realize you can't really bring 5e minus 3f back to 45e minus 27f, right? If you look at the yellow one, if you apply the distributive property, 9 times 5e is 45e, 9 times negative 3f is negative 27f, okay? So that's the back, it's actually the backwards distributive property. You can divide both sides by x, right? So x squared is divisible by x, and 6x is also divisible by x in this case. So yeah, I'm gonna have to cover this again next lesson. Okay. Oh. For that last question, it should have been x squared plus x. So distribute. Okay, good job. Last question. I think there are two correct answers in here. Okay, awesome. Hey, thanks for playing, Aaron. Are there any questions you'd like to ask me about the distributive property before you leave? Or are you fine?
Yeah.
Yeah, okay. Thanks for staying. I'll see you next week. Bye, guys.
Fine.
See you, Garrus.